All right. Well, welcome to my talk. I am Brett Hawkins, and this is a talk about a Windows persistence toolkit that I built called SharPersist. So kind of an outline of how today's going to go. I'm going to go pretty quickly through the slides because I have a lot of content I need to get through, and I want to make sure there's enough time to go through the demos. But first, I'm going to go over an overview of Windows persistence. I'm going to give an overview about SharPersist. I'm going to go through the different techniques that SharPersist has, and then I'm going to go through the demo. About me, I'm a red team consultant at Mandiant. I've been in InfoSec for about 8 years now. Did some post-grad work at SANS, undergrad work at University of Akron in Ohio. Got some certs. I'm from Ohio. If you're from Ohio, you'll know why I spelled it like that. And also, I like playing sports and video games in my free time. So first off, why did I create this toolkit? I wanted to automate the addition and removal of multiple persistence techniques, specifically with reflective C#, without having to rely on PowerShell or using, built-in system commands like reg and sctask and sc. I definitely, as a red teamer, try to stay away from PowerShell as much as possible. And also, I wanted to bring awareness to the various techniques that are available on Windows. And nothing like this existed publicly until now. How did I get the idea for the toolkit? Just my experience from doing red team operations. I get to work with a lot of really smart people who are much smarter than me, and I get a lot of ideas from them. And then also, I had a bunch of kind of standalone persistence tools that I would use, and I wanted to combine everything up into one toolkit. I'm just going to touch on Windows persistence. So this is FireEye's attack lifecycle diagram, and specifically we're going to focus on maintain presence. So as red teamers, right, we spend a lot of time getting into an organization, right? You do all your OSINT, your social engineering campaigns. If you're doing social engineering for malware execution, you have a lot of R&D goes into payload execution now because of all the modern security controls, right? The last thing you want is to lose that access. It sucks. It sucks so bad. So you want to make sure, right, when you get that initial access, you want to have some type of persistence there so you can maintain presence. And so that was my focus with this project. So Windows persistence, right, it's any access, action, or configuration change to a system that's going to give an adversary a persistent presence on that system. And this is needed if you want to maintain presence on that system for any period of time, whether you need to maintain presence for days, weeks, months, years, whatever. And there's two key components when it comes to persistence. There's the persistence implant and then the persistence trigger, right? So the persistence implant is going to be your payload, right? HTA, EXE, DLL, whatever. And then the trigger, that's going to what actually causes that payload to execute. Scheduled task and Windows service are two basic examples, right? But without that trigger, that payload can't execute. So the goal of SharPersist was to help with the persistence trigger. Some well-known, public persistence techniques that are included in SharPersist, right? Windows services, scheduled tasks, startup folder, the Windows registry. There's some others, the MITRE attack framework link right there. I definitely recommend you check it out. Some not as well-known public persistence techniques. So scheduled task backdoor. So basically you can backdoor an existing scheduled task to execute an additional action. Another one is KeyPass persistence. So you can basically use a user opening their KeyPass database as a persistence trigger. And the other one is Tortoise SVN persistence. So Tortoise SVN is a common Windows client used for interacting with SVN repos. So with that one, the persistence trigger is basically any time that they try to interact with a SVN repo with that client, you can have that trigger your payload. So these three are all included in the initial release of SharPersist, but these ones are not as well known. So I just went through Windows persistence, very high level. Now let's get into SharPersist. So SharPersist is a command line tool. It's written in C#. It's compatible with Cobalt Strike's execute assembly or any other framework that supports reflective C# execution. It gives you an easy way to use multiple persistence techniques on Windows hosts. I designed it very modular so that new persistence techniques can be added in the future. I want to add as much as I can to it and as much as the community can to it. I also implemented some additional tradecraft in the techniques. So things like file time stomping and running persistence implants, minimized or hidden. We just released a tool this week. The GitHub link is right there. Also, we have a blog post on it. I'm going to be distributing the slides afterwards too. So if you don't get a chance to take a picture of something or write something down, I'll be distributing them afterwards. So the various switches are available. Again, the GitHub it has full documentation, examples, everything you're going to need to use the tool. but some different switches that are available. So you can specify your persistence technique you want to use, command to execute, arguments to the command, file you want to create or modify, registry key to create or modify, registry value, schedule task name or service name. Also specify the method you want to use, which I'll get into those in a second, any optional add-ons that you want to use for the technique, and obviously a help page. So I mentioned the methods. So there's 4 different methods, right? There's add, which is simply going to add that persistence technique. Remove will remove that persistence technique. Check, what this will do, it will perform a dry run without actually adding that persistence. So for example, it's going to check to make sure you have the right permissions, make sure you have the right switches, stuff like that, without actually adding it. So I highly recommend, running check before you actually do the add. The same checks are actually in, when it's trying to add or remove the persistence, but it's just kind of best practice, I think, to kind of perform a dry run. And then there's a list method, which you can list current entries for a persistence technique. So for example, if you want to list current entries in like the HKCU run key, you can do that with the list method. And then the optional add-ons, they apply to just a few techniques. So, and you're going to see the first one here in the demo. So there's ENV. That's for environment variable obfuscation for registry persistence. So basically what that does is rather than having your commands and arguments, stored in the registry value, it's actually going to be an environment variable. And then the other 3 here, hourly, daily, and log on, that's for specifying your frequency for the scheduled task persistence. So I just went over an overview of SharPersist. Now we're going to get into the techniques. So on the initial release, it's coming with 7 techniques. Again, the plan is to add more in the future, both myself and the community. So if you have any really cool techniques, please feel free. I'd love to talk to you. So it's initially releasing with KeyPass, Windows Registry, Schedule Task Backdoor, New Schedule Tasks, the Startup Folder, Taurus SVN, and New Windows Service. And you specify the technique you want to use with the stuff in bold. Again, it's all on the GitHub, right? So KeyPass, Reg, Task Backdoor, Startup Folder, Taurus SVN, Service, and Task. And of all the techniques that are available in the initial release, only 2 of them actually require admin privileges. So the Schedule Task Backdoor and the New Windows Service both require admin privileges. The other techniques do not require admin privileges. Although, like for example, the Windows Registry, there's a few keys if you want to use, you need admin privileges. But to just use the technique, you don't need admin privileges for that. So the first technique, KeyPass. So it's going to use the fact that the user is opening that KeyPass database as a persistence trigger. And the way it does it is it actually backdoors that user's KeyPass configuration file with a malicious KeyPass trigger. So there's a trigger system basically in KeyPass that can be used as a nice feature for our red teamers. Some tradecraft. It maintains the timestamp of the original KeyPass configuration file, and it's also going to run your payload implant hidden, so the user's not going to see it. And there's some really great references there, particularly the @206 article there has a great blog post on this technique. And I have example commands for each of these, but I'm not going to drill into these in detail because, again, the GitHub has everything that you're going to need. Just kind of this one, right? You're specifying the KeyPass config and what commands you want to execute whenever that KeyPass database is opened. But again, all that's on the GitHub. Next one, Windows Registry. Pretty simple. Use the Windows Registry as a persistence trigger by adding, specify key and value. Again, with tradecraft, it's got the environment variable obfuscation that you're gonna see in the demo. So different registry keys just for the initial release. I know there's tons of registry keys that you can use for persistence. This is just for the initial release. So there's 8. 4 of them require admin privileges. 4 of them do not. Another thing to note is that some of them, right, are the user specifies a registry value. Some of them do not. So for example, the registry keys with predefined values for persistence. For example, the logon script. The user init MPR logon script registry value. If that value is present in HKCU environment, whatever is present in that registry value will run whenever the user logs on after a reboot. So that's kind of the difference between the predefined registry values and the ones that are not. Currently, the environment variable obfuscation is only supported for the user supplied registry keys, but I plan to add that functionality to the predefined ones in the future. One thing I wanted to note with the example command for this, when you're adding persistence, so like the first example there is just a regular, you're adding persistence to like the HKCU run key with some value you specify. The second one is the same thing, only you're adding that environment variable obfuscation with the -o env. And then the third one would be an example of a predefined registry key. As you can see, you don't specify a value for that one. It does it automatically for you. Next technique, schedule task backdoor. So that's going to backdoor a scheduled task by adding an additional action to it. And that additional action will run after the first one is completed. So the only thing you're doing is you're modifying an existing scheduled task. You're not creating a new one. You're just adding another action after it. Something to note with this, and it's the same for the scheduled task persistence, like the list method. You can list all scheduled tasks, you can list scheduled tasks by name, or you can list scheduled tasks by frequency if you just wanted to see all scheduled tasks that run at log on. On the blog post, you probably saw an example of this. Basically, I was listing all scheduled tasks that run at log on, and then I backdoored one of those. Next one, new scheduled task. So it's going to create a new scheduled task under the current user's context, except for if you want to specify one to run log on, that's going to require admin privileges. You can specify the frequency with the -O. If you don't specify frequency, then it's going to be created with a daily frequency, and that scheduled task will be scheduled to run at a random time between 10 a.m. and 12 p.m. local time. Why? Because most people are using their machines between 10 a.m. and 12 p.m. local time. And again, the usage is going to be the same as the scheduled task backdoor. Windows startup folder. So what this is going to do, it's going to create a link file. It's going to place it in the current user startup folder. Some tradecraft with this one, it's going to timestamp the link file between 60 and 90 days before the actual creation. Why am I doing that? Basically, if the blue team has any sort of scripts running on host to see recently added or modified files, like within the last 30 days or something, this will make sure that it's not caught in that. And also, it's going to run the link file minimize as well, so the user will not see it. Again, pretty basic examples there. Not gonna go through them since we're all on the GitHub there. Tortoise SVN. Okay, so this uses a hook script feature in Tortoise SVN as a persistence trigger. So basically, every time a user tries to connect to a Subversion repo with that client, that persistence trigger will activate. This could be if they're doing an SVN update, commit, checkout, just looking at a commit log, whatever. So basically there's a registry value that the hook script feature uses that you can specify system commands in there. And it will run the payload implant hidden as well. And this is very straightforward. The list method is not supported with this one right now, but again, I plan on adding it. And the last persistence technique is going to be new Windows service. Again, very common one, pretty simple. Registers a new Windows service, and it's going to be set to automatically start upon boot, and it's going to be running as a system. And with this technique, kind of similar to the scheduled task and stuff, you can list all Windows services, or you can list just a specific one. All right, now time for the demo. Is there a particular technique anybody wants to see first? Good, what? Scheduled task backdoor? Okay, you got it. Okay. So scheduled task backdoor, right? We have this privileged beacon right here on A. Dumbledore's machine. So what we're going to do here is we're going to list scheduled tasks that run at logon. All right. So we're going to see here. We're just going to choose just a random scheduled task to backdoor. This service restart task logon. You can see here it's got this initial action right here, right? So that's what it's scheduled to run, right? So then what we're going to do is we're going to backdoor the scheduled task to run our MS build payload. Add that in there. You can see here, it's all right, scheduled task backdoor. Now we're going to list that scheduled task out, and you're going to see the additional action that was added. Run that. All right, so you can see here, right? There's the additional scheduled task action. The only thing we did was we just added an action to it. Everything else stayed the same with that scheduled task. So defenders, make sure that you are looking at more than just the first action. So then to remove it, very straightforward. Sorry? So yeah, so what it uses a .NET library that is a wrapper for the scheduled service COM object. So you can see here we removed the backdoor, and then we're going to do list, and you can see there the original action's back. All right, let's go to KeyPass next. So you can see here we have an unprivileged beacon right here. Because again, this does not require privileged access. I'm going to open KeyPass database here with all my super secret passwords. You can see here, function just like normal. So now what we're going to do is we are going to backdoor this KeyPass configuration file. First thing we're going to do is we're going to use, I mentioned the check command, so it's going to go through various checks to make sure that we have the correct arguments, we have the correct permissions, make sure it is a KeyPass file. In this instance, making sure the KeyPass process isn't running, because if the KeyPass process is running, that config file is being used and I can't modify it. So you can see here all the checks pass. So we're going to go ahead and add this persistence technique. And again, what's going to happen is once we open the KeyPass database now, it's going to execute our payload and we'll get a beacon. And it's going to execute it all hidden. So what it's going to do is it's going to create a backup of the original file, and then it's going to modify the existing file. So you can see here we have the KeyPass database backdoored. I just opened it. Everything's normal, right? Nothing's popping up on the screen. However, our payload is executing in the background, and then you're going to see our beacon come in. There it is. All right. So then removing it, very straightforward. You're going to specify the KeyPass configuration file, remove method. And you're going to remove it. And what that'll do, that's going to take that back file, restore it, and then remove the backdoor KeyPass configuration file. Let's go towards SVN. All right, so for this one, I didn't have an actual SVN repo set up, but it doesn't matter. The fact that the client's trying to make the connection is what the trigger is. So here we have an unprivileged beacon on H. Potter's machine. Yes, I like Harry Potter, as you can tell from the username references. So you can see here, we're trying to do a SVN checkout. And again, I don't have one set up, but it's still trying to make that connection. So it's functioning as normal right now, right? So now we're going to add this tortoise SVN persistence. And again, we're going to have it execute our MS build payload, and it's going to be all hidden. Add persistence. You can see it's done. Now, when we go back to use the tortoise SVN client, again, we're just going to check out. Again, this could be anything. It could be you're trying to do an SVN update, commit, doesn't matter. Any sort of action with that client to communicate with something, that's what the trigger is. So right now, we're trying to do a checkout. Our payload's running in the background. And then we're going to see our beacon come in. Again, what this is doing in the background, so there's our beacon. What this is doing in the background is it's adding that to that hooks value registry key. If you look in the code and actually on the wiki page for this technique, you'll see the exact, list out the exact registry key and value that it uses. Then to remove it, very straightforward, specify the technique of tortoise SVN, remove it, and it's gone.
Okay, Brad, I have a question for you.
Yeah.
When you do the remove function, does it remove the trigger, or does it remove both the trigger and the payload?
It's just going to remove the trigger. Oh, yeah, so the question was, whenever you do the remove, does it remove the trigger and the payload? And the answer to that is just removes the trigger itself. So we're going to go over the registry here. I talked about the environment variable trick, so I do want to show that. So here we have an unprivileged beacon. All right, so we're going to list out the HKCU run key. Right now, you can see we're going to list this out. There's nothing in there right now. So now what we're going to do is we're going to create a persistence entry in the HKCU run key, but we're going to use the environment variable obfuscation. So you can see here we're creating a value called DerbyCon and having it store our MS build command execution, and we specify the -O of env. So now when we list out this registry value, our command and our argument we specified is not going to be present. What's going to be present is the environment variable, right? And then the actual command and argument, for example, for something in HKCU is stored in HKCU environment. So therefore, your command and argument is not actually going to be present in there to kind of hide it a little bit. So then to remove it, again, if you add something with the environment variable obfuscation, make sure when you're removing it, you also specify the env because that is also going to remove that environment variable. You can see here, we're going to do remove and specify the option of env, and it's removed. You can see here we're going to list it, and it will no longer be present. Right. Let's see here. What technique you guys want to see for? You want to see schedule tasks, Windows Server, startup folder? Any preference? No preference. All right, we'll do schedule task. So we had a question earlier. He was asking, is it using the Win API for the schedule task? It is using a .NET library that I referenced on the GitHub page that is a wrapper for the scheduled task COM object. So in here, we're going to create a scheduled task called DerbyCon. We have an unprivileged beacon. The scheduled task does not exist. So then we're going to create a scheduled task called DerbyCon that's going to execute our MS build payload. We're specifying the frequency of daily. Again, you don't need to because if you don't specify a frequency, it's just going to do it automatically at daily. So here we created the scheduled task. There's our scheduled task. So you can see it's set to run 10:57 a.m. And yeah, that's all there is to it right there. And removing it's very straightforward. You can specify the schedule task name, remove, and it's gone. I have time for one more technique. I'm going to go over the startup folder. So again, we have an unprivileged beacon. You're going to specify, first we're going to list to see if there's anything in the startup folder. I don't think I had anything in the startup folder for this one initially. Yep, so there's nothing in the startup folder right now. All right, so now we're going to add a link file called DerbyCon. It's going to go in the startup folder, and we want it to execute our MS build payload. So here it gives you the SHA-256 hash, gives you the full path to where it was created, and you can list that out. All right, you see it right there. It is. We're going to remove it. Maybe. Remove. And that's all there is to it. So it looks like I ran out of time. If you have any questions, feel free to hit me up on Twitter. Come talk to me afterwards out there. I'd be happy to talk with you about it. Lastly, just wanted to say thank you for coming to my talk, and also thank you to the entire DerbyCon staff for putting on a great conference. Thank you.